Okay, am I audible, Ashutosh? Am I audible? Harshal, are you there?
Yes, sir.
Okay, okay. Harshal is there or not?
Yes, sir, I'm here.
So we will be starting with the first topic, that is low cost automation. Because now we are still working under constraint, so otherwise I could have started directly with the microprocessor because it gives you more time for the practice and understanding of the programming. But it is not really possible in simulation, so I think we can start with this topic, that is low cost automation, and lot of elements or machines which are involved here are mostly the mechanical elements. So probably you will be able to understand it better. So firstly, why this particular thing is called low cost automation? If you go through the books, a very specific definition is not there, but there are few possible things which are given by certain people. Like we are having one productivity council. So there they have given some definition, then some other by Festo. Let me just tell you people that Festo is one of the leading companies which are using these low cost automation circuits. When I taught this actually with the MTech people, I shared with them one webinar. So it was of around approximately 1 hour. So it has given the entire idea to them what is exactly low cost automation. So if you people say I will run over here, other or I will forward you the link of that webinar later on, you can see that also. If you see that webinar, then you will be able to understand. Now we are going to study these circuits in isolation, but how does it work? What is the scope, exact scope of this particular topic when you are working in industry? How it is being implemented in different sections, in different companies, or in different applications. So it makes your ideas very clear about this low cost automation, especially nowadays when we are struggling with this industrial slowdown and lot of restrictions are there. The need is there for this low cost automation. So you let me know about this. So if you otherwise I will be putting over there in your Google Classroom. You can just go through that webinar. As far as the definition is concerned about this low cost automation, so there is one peculiar thing about the France, especially associated in the energy sector. Anybody knows about that specialty about the France? Because this particular one of the definitions is given by them. The people working in France are associated especially in the energy sector. No, nobody knows. A very less amount of countries are actually able to do that. Lot of countries have tried, but then they could not proceed beyond certain limit. So okay, so now energy production. If you see the energy production, suppose for example, if you see our country's energy production, uh, 80% of the energy is still being produced by thermal energy. Rest of the around 20% pertains to all different sources of energy. Wind power is there, hydraulic is there, then nuclear power is there. But there is a peculiar thing about the France that they are producing something around 25% of their energy requirement from nuclear power plants. So no other country is being able to do it to such an extent. So now with this, if you are if you have seen these nuclear power plants or you might have studied, these consist of very complicated circuits, and the requirement is that the operation should be very specific, very accurate, and it should be of least maintenance. So all such things can be only possible in low cost automation circuits. So they have extensively used this low cost automation circuit, and then with reference to that they have given one definition about this low cost automation circuit, that these are the circuits, whatever expenditure is required to form these circuits, that expenditure can be recovered during the same financial year. So if you are implementing one of the circuits in 21-22, then you will be able to recover that cost in the same year. So it is that low cost. But that is about, you can say, from finance aspect. But what others people have given the definition is that you can form the circuits with whatever little available components. What components basically require? These are the actuators. The actuators may be motors or cylinders, or you require the valves, different types of valves. That's all. And basically, you require a compressed air. So one compressor, small compressor. Now another constraint is there. The low cost automation circuit, which are working with the air medium, they are having a limitation. You cannot deploy them in a situation where you require more amount of pressure. That is, if you require pressure more than say 10 bar, 12 bar, then these circuits are not used. So preferably these circuits are working within the range of 3 to 8 bar. So always remember, for these low cost automation pneumatic circuits, so you cannot cross that limit. And suppose unknowingly if you cross it, so this has happened a few years back in our lab itself. That is, that actuator or cylinder directly explodes because it cannot sustain that amount of pressure. So that is what happens. So the setup which we are having in our lab, it is actually, we are having one connection from the heat transfer lab, which is at the ground floor. So that heat transfer lab has a bigger compressor. It can produce up beyond 10 bar also. So we have set the limit up to 8 bar for our lab. So we are regulating with the wall. Sometimes, if you are not regulating it, then such kind of incidences can occur. Now, currently, the lab is also under renovation. So entire lab is getting renovated. We are getting whole lot of new equipments. Now this is being donated by one of your seniors. He was having his own company, so that company is actually renovating and giving lot of new components now, new machines. So once it is over, in say 10-15 days, so I will prepare one of the videos for the machines which are there in our lab, so that you will at least be able to understand what kind of setups we had. So whenever you are back later on sometime, then probably we will consider the practicals on that also. So we are having two setups. That is, one is we can say modular setup. Modular setup means you can just think of one circuit, and modules are available. You just connect those modules with the compressor. You will get the compressed air, and with that you can initiate the actuation. Now we will start with the basic part of this low cost automation. I will try to share PPT now. So this is pertaining to the different types of, actually, not only the walls but other elements also, actuators also. So what different types of walls elements is being used, that we will go through first about this low cost automation. Some of these elements you might have seen earlier in probably there is one topic called fluid power. So the first actuator, see, there are two, basically there are two types of actuators. One is the reciprocating actuator, that is you can imagine with the help of piston cylinder arrangement. And then another say, actuator is the DC motor, that is rotary actuator. DC motor, stepper motor, these are rotary actuators. So here we will be concentrating on the reciprocating actuators, but because whatever circuits that we will be forming will be all with this actuator. So there are two types possible. One is the single acting cylinder, another one is the double acting. Now this single acting cylinder means you can imagine on the left side there is a cross sectional diagram, and on the right side it is a symbol. So it is a cylinder in which air pressure is applied to the movable element, that is piston, in only one direction. So that is why it is called single acting cylinder. So if you are supplying the air from one end, it goes to the other end. And then spring return cylinder is there. So in that spring return cylinder, a cylinder in which a spring returns the piston assembly. And that is what happens over here. So now you can see there is inbuilt spring. So it is about from design point of view again. So suppose you apply air pressure from one side, piston goes to the other end. Now you can design the stiffness of the spring or select the stiffness of the spring such that once the pressure which is applied get exhausted, due to the spring force, piston will come back to the original position. Currently some of this imagination probably you will it will be difficult for you to imagine, but later on I will show you some videos and some simulation. So with that your ideas will be clear about it. All these components can be simulated. All these components you can see the cross sectional features, actual flow of air, that also you can see. Um, One thing is there, actually I will do it right now. Some of you can try later on. There is one software, means whatever if you are not coming to the campus, we will be starting at least with this software which you can try downloading. So this is a fluid sim software. It is free software. It is free for the students also. You can just register over there. It will ask you for details, and then you can download it. So you can just keep it with you. I will show you some videos pertaining to that software also, how to construct different circuits and how to actually use that software. So you can try within a week's time. Later on, when after week's time, we will be having practicals. So as I told you yesterday, we will be having practical only on the Wednesday slot. Wednesday something 11 to 1 we are having. So all entire class will join over there. The half batch which normally goes to RAC lab, that won't be there on Wednesday. Then the next actuator or cylinder, what we can call it, double acting cylinder. Obviously, it is a cylinder in which air pressure may be alternately applied to the piston to drive it in either direction. So in whichever direction you want it to actuate, so from the both directions, air supply is possible. So on the left side, you can see the cross-sectional part of this, that is the diagram, and then symbol on the right side. So in the symbol, you can see two vertical lines indicate the supply from both directions. Another possibility is there, that is called double acting double rod cylinder. So again, the diagram is given over there. You can imagine it. So it is double acting cylinder with piston rod extending from each end. Now piston rods are connected to the same piston. Double rod cylinders provide equal force and speed in both directions. So for some special applications, now you may think why these particular arrangements are there, why this piston and rod arrangements are there. See, there are specific functions in industry. Automation circuits, if you have observed in any of the industries, if earlier we have visited this Siemens and other industries, so you need to carry out very small operations like conveying operation. Conveying means along the conveyor belt, say there is a batch of same 10 parts, you just want to convey it to the other destination, so you just put over there. This piston will hammer it out and then it can be transported to or conveyed to the next destination. Or carrying out means you can directly attach some of the attachments you can have on the piston side, and with those attachments you can carry it actually from one point to another point. The distances that all these are very shorter one, but that is specific requirement, then also that can be done. Then there are operations like hammering operation. So you just hammer it out to the batches, the batch of products, so it will get transported to the next destination. So such a small operations actually requires, but you know you're familiar that otherwise these operations were done manually, and then lot of resources are required for that. So these are the two possible features. Then these were the actuators. This is one of the most important thing that is called directional control valves. So what are these directional control valves? There are different types of valves are there, which you might have seen earlier. Anybody knows what different types of valves are there? Later on, there may be questions about different types of valves. So right now, the one cross section you are observing, but there are other types and which you might have used earlier in especially pertaining to fluid mechanics or fluid machinery. If you are able to recall those types of valves or you are able to identify, just let me know.
So butterfly one.
Okay, butterfly wire. Okay, we will discuss it. Any other type? Okay, non-return valve nivrutti. Okay. So these just now what you said is now okay, get wall. Yes, the purpose is same, Arshal. Okay, fine. These walls means what? Some of the walls are directional control. When you say directional control walls, these are just used to direct any particular medium. It may be air, it may be liquid. In terms of hydraulic, it is oil. So they are just directing it to some other location. That's all. That is the purpose of directional control wall. Now you just said the non-return wall, so that is you can say it is pressure unidirectional wall. So it is allowing to flow in one particular direction. Gate wall, these are some of those walls. So it is allowing to flow in one direction, so that is another type of wall. Then there are walls which we call it as pressure regulating wall. Pressure regulating wall, another name, the earlier one, not the wall. Check walls are, we also call them as check walls, which allows in one particular direction. We will see all these types, but there are other types of wall which we call it as pressure regulating wall. Means something like orifice kind of things is there, and then we are controlling air. We are regulating air as per our requirement. See, the requirement is there for most of these operations. You don't need to have any special equipment. need a uniform speed. Sometimes you require more acceleration, sometimes you require if you are throttling it as per your requirement, then you will be getting the output accordingly. So that speed regulation is the requirement for any industrial application, and that is possible with this valve, electrical supply. So similar here, these are the release. So all such types of valves are there. What happened? Okay, am I audible? I got disconnected. Some issue was there.
Yes, sir.
Abhishek, Aditi,
Present, sir.
Yes, sir.
Aditya, Amar, Aniket,
Yes, sir.
Anjali, Anushka,
Yes, sir.
Yes, sir.
Arnav, Arya, Ashutosh,
Yes, sir.
Yes, sir.
Atharva, Bhagyashri, Bhushan,
Yes,
Yes,
sir.
sir.
Yes.
Chaitanya, Gufran, Gurpreet,
Yes, sir.
Prasad,
Yes, sir.
Yes, sir.
Harsh, Harshada,
Yes, sir.
Yes, sir.
Harshal, Hemant, Kritik, Jay.
Yes.
Yes, sir. Yes, sir.
Ritik is there. Jay, Jayant, Jaivir Singh, Karthik,
Yes, sir.
Yes, sir.
Kaustubh, Kaveri, Manas,
Yes, sir.
Moni,
Yes, sir.
Yes, sir.
Mohammad Saif Ansari, Mrutyunjay, Mugda,
Yes,
Puneet,
sir.
Neha,
Yes, sir.
Yes, sir. Yes, sir.
Neha Korde, Nurian, Nikhil, Nishant, Nivruti,
Yes, sir.
Omkar,
Yes, sir.
Yes, sir. Present, sir.
Parva, Prafulla, Prajakta,
Yes, sir.
Pratik,
Yes,
Priti,
sir.
Rahil,
Yes, sir.
Rahul, Rajiv, Rakesh, Ravi, Ravi Desai, Ravi Parmar, Ritvik, Sagar,
Yes, sir. Yes, sir.
Sagar Gode, Sagar Nikam,
Yes, sir.
Sakshi Saloni,
Yes, sir.
Saltanat,
Sir.
Sarthak,
Yes.
Yes, sir.
Sarvari, Shivpriya, Shlok, Shreyas,
Yes, sir.
Yes, sir.
Shrikant, Shruti, Shubhangi,
Yes,
Siddesh,
sir.
Yes,
Yes,
sir.
sir.
Srushti, Suraj, Tanmay,
Yes, sir.
Yes, sir. Present.
Tejas, Varun, Vishwajit, Yash.
Yes, sir.
Yes, sir.
Okay, I think I have to share it again. So currently you are observing this directional control wall. So it is showing you the cross-sectional area. So simple thing is there, you can understand the arrangement of piston done over. That piston which is mounted on the rod, this entire assembly is called spool. So that spool is moving from one place to another place, and then it will block some of the air passages. It will open some of the air passages. So if you observe the diagram on the below part, there are two connections or two ports, we can say. These are possible. So one, they are calling it as pressure passage. So that pressure passage, it will be referred to as input pressure. So you can understand, if you are supplying air from that port, then it will go to passage A. Then from passage A, it is actually that passage A most of the time is connected to one of the ports of cylinder, which is not shown right now. When we will be having circuits, that time again you will be able to understand. But with that actuator, from the other end of the actuator, you will get the exhaust. So that exhaust is connected to passage B, exhaust of air. So now once it is connected to passage B, you can see the piston position adjacent to the passage B. Then it will allow it to pass through the exhaust passage. So it is then, you can say, vented out to the atmosphere. So this is the normal scenario how air travel will be there. There is so this is entire wall body they have indicated, and these are, you can say, four ports are possible. There is a nomenclature pertaining to this as per IS 5050, that we will see also later on. So this terminology or this particular cross section is pertaining to that. So this is how air now actually, we cannot see the air medium when we will be having videos there. At that time again, the air travel is actually indicated, and you will be seeing these circuits being simulated. So that time, but if you understand these constructional features, then only you will be able to understand the other things, that is symbols, drawings, circuits, everything. There are very, very complicated circuits also possible involving these all components. But basic thing is that you should understand these constructional arrangements, functional features. Otherwise, if you don't understand it today, then obviously those circuits you will not be able to understand. You can see here, with the piston positions, one of the ports is blocked. That is the first piston towards left. So it is blocking one of the ports. So now you can understand, if that left piston goes to the very left extreme, then that hole gets opened. But then how does, then in that case, the piston which is there at the right end, that gets that is blocking the another port which is there at towards the right. So this all happens over there. When we supply air, due to that air pressure, this movement of spool is there. That spool is the arrangement of rod and piston. But then what different other things are possible, that also we will see. Now here is the diagram that is showing you two different positions. So probably you will be able to understand it. So this is what the first arrangement which we have just seen. But now with this is the pressure inlet. So you are applying the pressure over there. You can see see the with the help of arrows. Then it goes to the cylinder. From cylinder exhaust, it is connected to B. Through B, again you can see the exhaust occurring over there. So these symbols and letters which are used over here, these are as per the sign conventions or procedure which is adopted in industry. That is P for pressure inlet, X for exhaust. A and B are mostly the connections given to the cylinder or actuator. So this is one of the possibilities. See, when you are applying air pressure at A, in the first position, that due to the air pressure, piston moves to the extreme end, to the extreme left. So if that is the scenario, once this exhaust occurs over here, after that, next time when you go pressure inlet, so that time you will not be able to give supply to A. You will be able to give supply to B. That is, you will be giving supply to the cylinder from the other end. So obviously, it has to be a double acting cylinder. It cannot be a single acting. So from P, you are giving supply to the other end of the cylinder, then it gets exhausted from A, and through A, you are allowing it to pass through to the exhaust. With dotted line, they have shown you. So it is something like circumference connection is there. So through A, exhaust is possible and it is connected to the EX. So this is how with the movement of the piston, air movement is taking place, and you can design the circuit as per your requirement. What actually is your requirement? To what extent piston should travel? What actually application you are having in mind? But this completes one cycle of operation. This is generally what we say. That is, with this arrangement, you are supplying it from the one end. Again, you are supplying it from the other end. So both the ends, extreme ends, you have actually done with the help of piston travel. And then in that case, we can say that one complete cycle is being performed. So this is how you can do that. Then the type of valves we will see about functional types. So these are the functional type of valve. First is obvious thing. The diagram is immediately next slide is there, so that make your ideas very clear. So here it is two-way valve. Now this terminology you will have to keep it in mind when you will be drawing symbols. Immediately after this slide, symbols are also there. So you should be able to show according to the functional requirements. So a two-way directional control valve consists of two ports connected to each other with passages which are connected or disconnected. In one extreme spool position, port A is open to port B. The flow path through the valve is open. In the other extreme, the large diameter of the spool closes path between A and B. The flow path is blocked. A two-way directional valve gives on-off function. Now, maybe you will not be able to understand this entire description, but once you see the diagram, so here you just first try to imagine what kind of possibilities are there. We have just seen the port position for the four-way valve. Four ports were there. So four ports and four ports, but two-way valve. Two-way means what? Two positions are possible, on and off. It is similar to your electrical switches. It is either on or either off. So either now it depends on how you are applying pressure, in which direction you are applying pressure. So obviously, if there are only two ports, the only thing that is possible, it will work like your switch. It will be on and it will be off as per the switch position. Now, let me just show you the arrangement so that Okay, can you see this is slide number 7?
Yes, sir.
So this is now two-way valve, two-way, two-port valve. Just now what we have seen the description. So I think you can understand it better. There is one terminology used. You might be aware about that. That is normally closed and normally open position. So the upper diagram indicates normally open position. For that cross-sectional diagram as well as the symbol is indicated. The below diagram indicates normally closed position, and for that the symbol and diagram is there. So you can easily understand in the first diagram, if you are applying pressure from below, then the other port it will allow it to pass through. You can just see the position of the piston. The leftmost position is there, and there is a right position. So the other piston has touched to the extreme end. So now it is allowing to pass through the air. Now once we have done with this cycle, the next position is also possible, that with the pressure application, once it gets exhausted, the spool will be changing, piston position will be changing. If the piston position is changing, it is blocking the first air supply. So obviously now there is no air supply. It will not be possible to pass through to the exhaust. Okay, so this diagram is self-explanatory, but here you can see, you might have studied in maybe electrical, I don't know about the capacitor or capacitance. That new term was all there in 12th also. So something like symbol is there, two parallel plates. So now why we are using such kind of symbol? Because it is used to indicate that there is a store of the charge, something like that. So here similar thing is the air is trapped in that wall body. So it may get exhaust, but right now you are not allowing it to pass through. So there a pressure inlet is blocked. So that entire connection is blocked. You are not receiving any air supply at the other end. So if that is the position, it is also called as shut off position. Since there is no supply of air, so it is called shut off position. So the same terminology you will have to use whenever you are drawing the diagrams. Uh, the currently what you are seeing for the normally open position, same symbol should be used. That is arrow they have indicated. In shut off position, you have to use the same symbol. So this is the possibility of symbol. Then we will see there is another type of wall, that is we can consider this as three-port wall. Now we can see this three-port wall. Now here it is again the directional control wall. See if at the left side you are trying to connect it to the pressure supply, but due to the piston position it is not allowing it to pass through. Okay, so that is the scenario. Then port A is connected to exhaust, so that is possible. With the exhaust of the cylinder you can allow it to pass through, but pressure inlet is not possible. So accordingly you can understand the symbolic position. So here one port is shown as shut off P. At the P location you can see the shut off symbol is there, and then the reverse arrow. That reverse arrow means it is indicating the exhaust. But when you are it gets exhausted with the pressure application, piston moves to the other side. You can see the change of position, that is at the right side. Now with this you are applying air pressure, it is passing through A, but then you are actually blocking the exhaust. So with that spool position or piston position, you can see different symbol. So in that different symbol, P is connected to A. So that is how the arrow is indicated, and exhaust is it is indicated as shut off position. So that is what how symbols are possible. This is how you can understand the functioning of the three-way wall. I hope you might have understood Varun, Tejas.
Yes, sir. Understood.
Tejas is there. Tejas, Shubhangi,
Yes, sir.
Tejas, double TT is gone.
Yes, sir.
Okay. Hmm. I understood or not, Tejas?
Yes, sir.
ये क्या नया तुम लोगों ने स्टाइल निकाला है ये वो ब्लैक स्पॉट एंड देन ओनली योर लेटर्स आर देयर ये बहुत सारे लोगों के पास नया नया स्टाइल है ये मोनिल तो पूरा डार्क एक ब्लॉक लेके बैठ गया है मोनिल इज देयर अच्छा अरे बाप रे निवृत्ति अभी ऐसा ठीक है but the other people should now we have not seen even today we have not seen any of you so probably you will not be able to recognize you people later on anyway so this is how Tanmay is there or not
Yes, sir.
Tanmay
Yes, sir.
understood or not so these things if you don't
Yes, yes, sir.
understand
Yes.
now yes so if you don't understand it now it will be very difficult later on because see lot of problems are there during exams you people skip some of the symbols some of the terminology and then it is of no use because the operation which you are expecting will not be there for example suppose instead of the forward arrow if you draw a reverse arrow the entire thing goes wrong so you are not basically going to get the operation so that is very important to understand these symbols all the symbols I have also clubbed together actually in the next coming slides all those symbols are also there so I think we can stop here for today I will share with you the attendance link some if you are having some doubts you can just put it over here in the feedback so immediately next time we will also try to sort it out those doubts okay so I will just put the link for the form then you can just Okay, I'll put the link over here. You can just mention your attendance and then you can leave. Okay, bye. Thank you.